Hi everyone. Welcome to the Mountain View Cloud Native Computing Meetup group. I'm Sam. I'll be your host today, and we also have Anjan and Lakmal on the call, who are co-organizers of the event. So just a bit about the event. Of course, this is to share knowledge on cloud native technologies and for you to meet like-minded people and to network. We usually do have these events on site, but because of what's going on, we have moved it online. During the talk, you can, of course, ask questions to our speaker using the Zoom chat. And during the talk, try and mute yourself so that you don't disturb the speaker too much. But he will answer questions as and when you ask them via the chat. And once once the talk is done, you can unmute yourself and have a discussion with the speaker and your fellow attendees. So today's meetup is sponsored by WSO2. They're a technology company that provides API management, integration, identity and access management technology to build to help companies build digital products. And they also have this really cool new programming language called Ballerina. It's an open source programming language that helps developers to build applications that need to communicate over a network, or if you need to push those applications to cloud platforms. And if you do want to engage with the WSO2 community, you can join any of these Slack channels and go ahead and get involved in the discussions. So today's speaker, hi James. Today's speaker is James Beswick. He's a senior developer advocate at AWS Serverless Applications. How are you doing, James?
Great. Sorry, just finding the unmute button.
Okay, great. I think you already have like an intro slide and stuff, so I'll let you get right to it. Thank you.
Sure. Okay. Thanks. Let me just share this screen with you. Okay, everybody. So thanks very much for joining me. I know it's probably late for some of us and very early for other people. So one of the great things about these virtual meetups now is that we're all from all over the place. So it's really great to see some people I don't normally get to see face to face. So my name is James Beswick. I'm a senior developer advocate here at AWS Serverless. And I've been a self-confessed serverless geek for quite a long time. And I've been a software developer for many years and a product management activist. I'm somebody who likes using technology to solve business problems instead of just building things for the sake of building things. I've worked in lots of different companies, including Rackspace, Morgan Stanley, USA, and I've been an AWS customer since 2012. So I've actually used a lot of things before serverless as well, so I'm fairly familiar with the way AWS works. And what I wanted to talk to you today about was about event-driven architectures. So in this talk, I'll discover a few different things. First, I'll talk about the basics of event-driven architectures and why they might be interesting to you from a point of view of your applications. And then I'll go through EventBridge, which is a fairly new service that can help solve some of the common problems with event-based systems. And we'll take a look at how that service works and how it fits into some of the concepts in the first section. And then I'll talk about some of the common use cases of how EventBridge can be used. And finally, we'll go into how it can be used beyond your application with third-party SaaS providers. And at the end of this deck, I got a few code demos and things I can show you as well. But obviously, your questions are a key part of this. So I'll be answering mostly those more than anything else. So firstly, here are some of the challenges we face in software today. Monoliths are everywhere. So we keep trying to break these down, and yet they keep reappearing. So you might have seen a slide like this before, especially if you've been to any sort of AWS event. And this talk is not about breaking down the monolith, but when you think about it, monoliths get a bad rap. They're very easy to build. They're easy to reason about and think about. And often they use one ACID compliant database, so they're simple to manage and maneuver. And distributed systems on the right are much more complex to put together. But the problem is that monoliths don't scale. They don't scale in terms of throughput of traffic, nor in terms of team sizes if you're trying to build large applications. So if you have large systems with dozens or hundreds of engineers, you end up having to move towards this microservices model in order to actually get throughput in your software. But monoliths do keep showing up. And so the end goal, what we're trying to do with all of this, is about achieving some of these things for our customers. We want to produce customer value and software that's reliable and resilient and scalable, and do it faster. And of course, we all work in environments now where we're not getting more developers and our teams aren't getting bigger, but the demands on IT and what software can produce are getting faster and faster all the time. So let's talk about some of these challenges as you get into building distributed systems. The first one is coupling. So one of the big benefits that's often cited for microservices are that they help build loosely coupled systems. But it's important to realize that as soon as you have more than a couple of different microservices working together, often they slide back away from being decoupled back towards being coupled. And so you need to think about some of the long-term ramifications for this kind of system. So in a simple example, the synchronous API, the sort of thing we've all built many of these many times, this is fairly straightforward. You have a client system calling an order service that turns around to an internal invoice service. The invoice service does some work, and then it then returns a 201 saying it was successful, and then that returns back to your client, and everything works great. And in this very, very simple example, there's obviously no monolith. This is two very clean, separate systems. And so it's fine when you've got this sort of clean break. But what tends to happen is that over time, more and more systems get integrated. That tends to be really true if you're building microservices that are useful to people in your company. So what happens when you've got your order service in this case is that people downstream want to then consume things and attach themselves to your order service. So the order service starts to get more and more responsibilities and more complexity. And from a team point of view, every time another downstream service appears, they have to then decide to queue it up and integrate it. And it means they're not actually getting features built on their own system. And if each downstream service has its own API, the order service is responsible for talking to each of those. And if there are any backwards incompatible changes to those APIs, then the order service team is on the hook to update those. So over time, these sorts of services become more like this. You start to find there's more and more downstream systems. And what happens is that those downstream systems get blocked by the order service who don't have the time to integrate them necessarily. And then these teams are no longer operating independently. And so when you have all this friction of putting these things together, it slows down all of the development process. And so the decoupling ends up being gone, and it actually ends up looking much more like this monolith that we started to get away from the very beginning. So what can we really do about this? Here's another problem. So choreographing APIs can be very hard. So as APIs develop into complex workflows, it can be really difficult to make sure that each service has the right state. So if we look at a simple e-commerce application with some added downstream services, I put there fulfillment and shipping. In the happy path, everything works just fine. You have the order service talking to the invoice service and the payment service. That triggers fulfillment, that triggers shipping. And then this is all great until there's a slight problem. And so if you imagine now we're out of stock, the fulfillment center physically doesn't have the product that's been ordered. So they may then have to send an alert to the invoice service there's a shortage, then tell the payment service to issue a credit or a refund or something. And then the shipping may have already been triggered, so something has to then manually be sent back from there. And it may turn out that the forecasting service just doesn't accept these kind of updates. So the numbers are wrong, and you have to go and manually change this. And so, and this is just one type of error you might have in one service. If the error occurs somewhere else, you have the same sort of flow where errors are coming from different places. So another type of problem with this is that you get another service added. It's very common. You know, in this case, we've shown a reward service gets added, but it's very common that a team will come along and attach themselves to your infrastructure. Did you know this service was added? You know, if you're in the payment systems and you weren't told about the reward service, and that same fulfillment error happens, and basically all of those messages have been sent out like before, everybody's told except the reward service. So essentially, a customer gets rewarded for an order that was canceled. And so the reward service then upgrades itself and gets a new vendor. Did anybody know about that? So now there's different versions of different vendor software living in this system. And so this starts to become incredibly hard to choreograph, and it's one of the reasons why these systems become very fragile very quickly. And here's one more issue for you. So availability in these systems when they're synchronous is another problem. So if you look back at this, where we have this synchronous connection, if the order service and payment service are connected like this, then when the payment service goes down, the order service also goes down, at least from the perspective of the customer. And this often happens when you have mismatches of speed. You put the payment service, which typically would be slower than an order service, and they're connected synchronously. So in this sort of setup, putting a fast service in front of a slow one isn't a good idea. So we could look at events as a way of potentially solving these three challenges that I think lots of us have seen over and over in these large, complex distributed systems. So what is an event? Well, an event is basically just a signal that the system's state has changed. And often in these systems, that's a piece of JSON. It's a JSON object that has some set of facts about the change and potentially the new state of the system. And an event has certain attributes. It's often a set of facts, it's immutable, it's observable, and it's temporal. When it happens matters in the flow of things. So in order to understand how events can help solve some of this, we need to talk about another factor about this, which is events are asynchronous. So in the synchronous model, like on the left, where a client calls service A, which calls service B, the client is blocked until service A returns, and then service A is blocked until service B returns. And so there's a lot of waiting in these systems. It makes them very hard to extend. In asynchronous systems, it's different, where the client makes a request to service A immediately acknowledges the request once it's been durably stored. And then the client can go on with their own work. Meanwhile, service A sends to service B. These things become separated and they're moving in parallel. Now, I said something a bit earlier that actually is an interesting part of events, and I think is one of the key parts of why all this is really worth thinking about. Events are observable and not directed. So if you think about a directed system where you have the person on the left say, please create an invoice, and then the person on the right responds to that and does some work. If more people are added, the person on the left has to really keep track of what each of these people are doing. In the case of observable events, it's a bit different because the person on the left here simply says, custom X ordered a widget. And then the person at the back hears that and decides to add it to a sales report. Another person hears it, decides to add it to an invoice. And two other people hear it and decide to take no action at all. And the key thing there is that the event producer, the person who said customer X just ordered a widget, actually doesn't need to know who's listening. So it keeps them very simple. They just need to say what's happening. And it means other services can come online, in this case people, consuming events without needing any sort of upstream changes to integrate. So that's really interesting, but if you go back to our order for service example, how do you then implement that? How do you pass information from the order service to these downstream systems without actually calling them directly? Well, for that, you need an event bus. And so this provides an endpoint where the event producer can send events. So the router here manages the directing and filtering of these events to the appropriate downstream consumers, and the consumers get the events that they care about while being decoupled from the producer. So in this case, the architecture actually looks very similar, but we've just put this event bus in the middle. So the order service gets to send the events to that bus, which is configured with rules that determine what happens to the events when they arrive and who they should be routed to. So some targets only care about certain events, others want to see all the events, and either way the router takes on the complexity of ensuring that events get routed and propagated to each downstream service that needs to hear about them. So back in our example with an event bus decoupling, it's actually very similar, but if that fulfillment system has an error like before, then it raises an error event. And anybody who is interested in that type of error event can listen for that and take action accordingly. Additionally, if we think about the problem of when a new service comes along, like the rewards service, actually it's very simple here because all they have to do is listen to the event bus. You add a new rule to the event bus, and now a reward service can take part in this event messaging as well. And there's no need for any of these systems to integrate with the order service directly. So the order service team at this point actually doesn't need to know who's listening to these events and can keep developing features as they need to. And so the overall effect of this is that teams can now move faster and more independently. So in this version with Event Bus, in the middle, basically your services consume and produce messages off an event bus, and they don't do that from each other anymore. So I'll show you later some of the code and what that looks like, but actually it makes things very, very easy. So as applications expand to include other systems that are beyond your immediate control, you need to pass information to and from those services, but it can be kind of difficult because you don't own the code for those systems. So it's hard to get that information. So what can you do? You've got a third-party application or a SaaS provider on the left and all of your systems on the right. Well, there's a few different options. The first is polling. That's been around for a long, long time. And if your SaaS provider has an API that supports this, you can build some sort of poller function, maybe a Lambda function, that can sit there and ping an API asking for updates. Maybe you have a cron job or a scheduler or CloudWatch events or something causing that to happen. Now, in this case, this is okay if payloads aren't too large, but actually it's kind of a last resort option because what happens with polling is you get a lot of unnecessary traffic. A lot of time you're polling for changes and there are no changes to report. So it creates a lot of extra load on the SaaS provider and on your own systems. There's also a lag. So if you poll every 60 seconds and you've got distributed data, on average, you're going to find that you're 30 seconds out of date just from the infrequency of the events. And of course, this is something you have to manage. So with a polling function, this is another piece of infrastructure that your team has to manage. Now, the second option, which is a lot better and has been around for quite a long time, is webhooks. So with webhooks, in this case, you have provided the SaaS provider with an HTTP endpoint, and they post or get information to that endpoint when new information becomes available. Now, you might use something like a custom authorizer to validate the calls and secure the endpoint. And one of the benefits here is this is much closer to real time. But there are pros and cons to this approach. So in the pro side, it's actually much simpler than you might think because it's just a get or post API call. It's definitely more efficient than polling because the webhook isn't being called unless there's some information to report. And you do get to this closer to real-time effect of the data transmission. But there are some disadvantages that people often don't think about with this. If your service on your side is down for any reason, often your SaaS provider isn't aware of this and they'll not retry the data for you. So it can be data that's lost. Many times there are limited security options using static API keys and that kind of thing, which isn't ideal. It is more infrastructure to manage. It's a public HTTP endpoint, so you have to secure that. It's on the internet, so you have to think about that too. And it can be difficult to scale. So often if you're dealing with a SaaS provider, they can be very large businesses creating lots of different events, and they're sending them all to your endpoint. So if you get lots of traffic, you need to figure out how you're going to scale up that endpoint to receive those events. So the question is, can we do better than this? Can we do better than polling and webhooks? And we can. So we've got this new service called EventBridge, and that was launched at the AWS Summit last year in New York. And this really is an attempt for us to make events a first-class citizen within the AWS system. And so it's a serverless event bus service. So there's no servers, there's nothing for you to manage at all. And it's there to help you ingest and route events. And these events could come from AWS services or SaaS applications or your own systems. So EventBridge came from CloudWatch events. It's not a brand new service. It is an evolution where we took what was working there for years and added a bunch of new features. And so as a result, it's already processing trillions of events per month. It's absolutely a massive system. So I mentioned that it's serverless, and it's worth just mentioning what that means because I know it's new to a lot of people. So in the case of serverless systems, the key tenets are that there's no infrastructure for you to manage. Obviously, there are servers running these systems really, but they're not managed by you. So typically in the serverless space, that means that the service will scale on your behalf. It'll patch itself, operate itself. You don't need to think about how it's really working. It also, from a point of view of cost, means you pay for value. You're paying for when you're making calls and using that service. You're not paying for it to sit around. And typically within enterprise IT, if you have virtual instances or servers, you're actually not using them 100% of the time. So you have a lot of wasted expenditure sitting around in servers. In the case of something like Lambda, you pay per invocation. So you literally don't pay at all if you're not calling it. And these systems are designed to be very highly available and secure. So, AWS security is job number one. You hear that a lot if you work here. So these are really designed to be extremely resilient systems. Now, how it fits into the broader scheme of things is serverless is a series of services, but you have functions as a service, which is where we run code on demand. And in the AWS space, that means Lambda. So you provide your code in the form of a Lambda function, and we make it work. And the way it works is it responds to events. So any sort of event in the system will then trigger that code. So if you think about what an event source could be, it might be a change in data state in a database like DynamoDB, or it could be an endpoint request like an HTTP request, for example, or a change in a resource state. Or it could just be a cron job. It might just be a schedule that causes it to run. But in each case, there's an event that causes the trigger. Now, the function itself in Lambda can be written in lots of different languages. It could be run in Node.js, Python, Java, Go, Ruby, .NET. And you can actually bring your own custom runtime too. We have people running PHP, Perl, Erlang, even COBOL in some cases. So it's really just an execution environment where you can bring your code and it'll run. And then Lambda itself can integrate with any service within AWS, but also beyond AWS. So if you wanted to talk to services like Stripe for payments, you could do that. Or if you wanted to work with Auth0 for authorization, you can do that too. There's nothing stopping a Lambda function talking to anything on the internet. Now, the execution model with this is also worth just mentioning very briefly because it's a little bit more involved than people might think. So in this case of a synchronous API, where you have an API endpoint calling a Lambda function, the API endpoint is waiting for a return value from the Lambda function, which goes back to the client. In the case of asynchronous events, like with SNS or S3, when those events come to Lambda, they've actually been decoupled via an internal queue. So there's no way to return values back to those systems. At that point, the Lambda function cannot return anything back to the thing that caused the event. And then you have stream-based systems that come from Kinesis and DynamoDB. So in this case, Kinesis produces enormous amounts of data and can use Lambda functions to transform that data. So what's happening there is the Lambda functions are receiving batch of events off of internally managed queues. But each of these services have different ways of invoking this code. So with EventBridge, some of the things to think about are that it's totally managed. As I said, it's serverless, so it's pay as you go. There's a free tier allowance where you get 1 million events per month for free. So you can try this out as a developer and really use quite a lot before you'll get any form of bill. It has native integration with 25 different SaaS providers. These are companies like Datadog, PagerDuty, Auth0. And it also integrates with 90 plus different AWS services and 17 AWS services as targets. And so there's no actual cost for delivery of events, and there's no cost for sourcing events from AWS services. You're only charged when you put events in from your custom applications or your SaaS applications. So what does it actually look like? So on the left-hand side, you have event sources. So these are AWS services, custom events, and SaaS providers. And then in the middle, you have your event bus. So every account has a default event bus that's there automatically. You have the option of creating your own custom event buses as well. And then if you're using SaaS integration, then you have partner event buses where those events will be arriving. And then on the right-hand side, you have targets, which are places where you want to send events that match rules. So the rules are the interesting part. So here's an example event that's coming in. Here is a ticket to say, an event saying a ticket was created. It's got a ticket ID, a department, and a creator, and a source. The source is very important. That separates out AWS events from partners from your own applications. And in this case, we could create a rule that says, I'm interested in events where the source is an AWS partner of example 123. I could also have more detailed rules where I specify multiple parameters. In this case, a department that matches either billing or fulfillment. The event on the left would match because it contains a department of billing. In this case, this rule would not match. So here it's looking for a detailed type of ticket resolve. The event on the left is ticket created, so this would not match. So then once you have rules that do match, this is where it gets sent on to a target. So a rule can have up to 5 different targets. And targets let you do things like invoke a Lambda function, or put a record on a Kinesis data stream or fire hose, or start the execution of a step functions workflow. Or you can even do things like starting a task using ECS or Fargate. So let me show you what this actually looks like in terms of code. So if we think about that original example we talked about with the order service and the invoice service, this is pretty straightforward. The order service is going to raise an event to the invoice service. So with the event bus in the middle, it looks like this. So it's going to essentially decouple these two services. Well, actually the code is very simple. So in this case, the order service on the left, and we're using Node.js here, but you could use any runtime that you prefer. It constructs a parameters object in JSON. And you'll see that it contains a lot of those parameters we saw earlier. We've got a source of demo.orders, and here we've got a new order with some detail and order ID. And in real life, you can actually put a very, very large amount of data in here. The payloads can be significantly bigger, but just for an example, this shows you what a minimal order could look like. And at the very end, it calls the put events method on EventBridge to put that in. And you'll get a response back at 200 once that event has been durably stored, which in AWS means we've written it to multiple availability zones. So now in the middle, we create this event rule. And the event rule simply says, we're interested in listening to a source of demo.orders. We want to look at created detail. The state enabled means the rule is in effect. And then when we look at the target, that says, if this matches, I want to invoke the invoice service function, and we put in the ARN and give it an ID. And then over on the right, you have this invoice service function that you'll see actually in this case doesn't do very much. It simply receives the event and logs it out and returns a status code. But the critical thing is the invoice service actually doesn't know where the event came from, nor does it care. It doesn't have any relation to the order service. So this actually is part of the power in how this works. So really within 20 or 30 lines of code and configuration, you can use an event bus in your software. So remember we talked about this reward service earlier and where that came from. So what can you do if you want to add an extra service in this case? Well, actually it's pretty simple. All we do is we add an extra target here. We can say that we want instead to route to a second target, a reward service using the same rule in this case. And so now what happens is when the order service raises this one event, it gets routed to those two different functions. And there's been no code change in the invoice service or the order service. And so they're completely unaware anything has changed, which I think is really the key, one of the key powerful things about this kind of design. So a few other quick things around this that I think are really interesting. So events aren't new, they've been around for a very long time. And one of the older problems of this was that if everything you have in your infrastructure is generating events, you have an administrative problem of just trying to keep track of what the events look like, the schema. So as different microservices produce different types of events, and there are version upgrades and changes, and you've got your events versus AWS and SaaS providers, it's really tough trying to keep track of what these things look like. So we released a product called the Schema Registry, which actually went GA today. It's now been launched as generally available. And so what this does is this can listen to events going through your bus and make sense of them. What it does essentially is it looks at the schema of these different things and creates bindings for you. So if you're using languages like Python or TypeScript, you can essentially download these bindings into your IDE directly. And that means you can start building software directly on objects that have been built by events. So when you turn this on, this makes the whole thing much more straightforward to manage and much more automatic. So if you're using an event source where something changes because another team has released a new version, that's how you become aware of what the new schema is, and that's how you manage it within your code. Now, there are some common EventBridge use cases that are just worth giving you an example of. Some are pretty obvious. If you want to take action on something, an AWS service does something, like an EC2 instance might be started, maybe you want to build that somewhere or want to run some sort of job, that'd be simple enough to listen through EventBridge and trigger a Lambda function. You might want to run a workflow. So if you've got some very elaborate business workflow, one of the ones I did recently was where if you want to automatically pay an invoice, you put the invoice in an S3 bucket, that triggers a step functions workflow triggered by EventBridge. Also, you may want to apply intelligence. So we do this with Zendesk, where in the case of a third-party provider, with like a SaaS provider, the ticket is created in that system and then sends an event over to EventBridge. This then triggers one of your Lambda functions, and you can use a machine learning service like Comprehend or SageMaker to make sense of the ticket. So if you ran a sentiment analysis on the ticket and find it's negative, you could go back and update the ticket to make it more urgent as a result. And so one of the neat things about this is that you can effectively extend the functionality of what SaaS providers are natively providing. Some of the other parts are being able to audit and analyze things. So if you have an infrastructure and an enterprise creating lots and lots of different events, you can use EventBridge to push this to Kinesis, and then that batches things up into objects into S3, and then use Athena to analyze that data. It's actually very, very easy to set up fairly sophisticated systems with lots of data. And also you can use this to synchronize data. So when you have a SaaS provider and your own internal system, you may have some sort of interface in the front, but there's other data going on in the background. You can use the passive information through the event bus to keep data in sync directly with that provider. And remember, when that happens, the SaaS provider is not going over the internet. So this is only going through the internet, the AWS backbone. So that sort of traffic is inherently more secure. So when you want to onboard a SaaS provider, it's actually very simple. So there's 25 different providers. Most of them follow this kind of pattern, but you simply register your account ID with the SaaS provider. And then once you've done that, that creates a partner event source that appears within your AWS account. You have to activate that event source to give it permission to be able to put events into your bus once you're back in your AWS account. So you associate that event source with an event bus. So you'll see in this example, it's called a partner example, but you would actually get the name of the provider, Zendesk, Auth0, whomever that might be. So once that happens, then you start configuring rules on that event bus. They just look like the things we saw earlier. It's JSON. You're simply building matching sets of attributes and parameters to see what you want to match on. And then you set your targets. So this shows Lambda, SQS, but there's 17 other types of target as well. So what I'll do is I'll show you I'll just jump to the end on that. I'll show you a couple of the examples that I've been working on that I think bring this to life. So I'll just close this presentation and move it over to there. Let me know, by the way, if you have any quick questions while I set this up. I'll be happy to answer them. Let me just close this down.
There are a few questions on the chat.
Great. Oh yeah, well there are. Okay, I've just saw the comments. Okay, so this is from Andrew's hard questions. Great. So how long does an event live on the bus? So when an event comes to the bus, it will retry a target for 24 hours. So if the target's unavailable for some period of time, it'll keep retrying it with exponential backoff. Now, if you have a rule that has no targets, then the event will just disappear because obviously it's got nowhere to go. And if you need to have an event that lasts for longer than 24 hours, and the best thing to do is to use SQS. You can have that routed directly to SQS if you need longer durability. If an event fails to pick up at my service, what happens to the event? Yeah, so this case, if the event has no target, it doesn't go anywhere, it dies. So there's nothing in the event bus that is like a database, and it's not a queue either. So essentially the event bus is like a router. Things come in and they go out, but if they've got nowhere to go, then they simply go nowhere. Put events have limits. If you hit this event, should you be using multiple buses, or is there a point at which you should use, the use case is different, you should use a NAT or Kinesis? Yeah, so put events have different limits in different regions. Typically, I think right now it's 2,400 transactions per second in US East 1, and it varies around the world. Typically, these limits are going up fairly rapidly. But these are soft limits. So if you have cases where you want to increase those limits, just raise a support ticket with AWS, and we'll be happy to raise that for you. Now, obviously, there are cases where you might have something that has an enormous amount of traffic. So, you know, event buses might not be the perfect solution for everything, but in many cases where you have lots of traffic, they work pretty well. And then you said Kinesis could also be used as an event bus, but would it be more labor intensive since you have to write producers and consumers? That is a really interesting question. So Kinesis could also be an event bus, but I tend to think of Kinesis as being something where you're receiving lots of data for processing in some respect, maybe running, you know, some sort of reduce function or something of that nature. I feel this is more where you might be receiving from lots of different producers and routing to lots of different consumers. So it becomes a central point for an application rather than just one part of an application. So could X-ray visualize a downtrace? Sorry, I just lost that, it's scrolled. Could X-ray visualize a downtrace across two services that communicate across EventBridge? Currently not. So currently that's not the case, but it's something we've been talking about. So hopefully we'll be able to do that in the near future. Is the schema registry akin to protocol buffers? I don't know what protocol buffers are, but I'd say a schema registry is more a way of, it's more like a phone book or some sort of way of tracking what an event looks like. So as you saw from the invoice and order events there, those are very simple examples. But when you look at events that come from AWS services, often they've got 20, 30, 100 different attributes. And so you need something that can keep track of the data types and what's going on with those events. So really that's what that is there for. So as a developer, you don't have to think about the actual structure of the event quite so much. Can the schema registry be configured to be backwards compatible for particular event types? That's a very good question, actually, George. I have to think about that because typically the way we've seen it being used, you know, events tend to have more attributes added on in versions, but I can see what your question is. Let me look into that one and see if I can get you a better answer, but it's a good question. So you're interested in the EventBridge passing messages to Kinesis and using the schema registry to read, record. Yeah, interesting question. Let me come back to you on that one, and I'll see if I can get you a better answer. Great question. So what I'll do is I'll show you some of the other things quickly, and then afterwards, you know, let's all come on this and chat online, and we can go through any other questions. So I've been working on this for probably about 6 months, and I found some very, very powerful things you can do with EventBridge I'm pretty impressed with. So the first one, I've got all these in these GitHub repos that you can check out. All of my GitHub repos are in my GitHub account of JBESW, and I tend to link these up to articles that I write on the Compute blog. So this one, I wrote this application before EventBridge came along that essentially looked at documents being stored in the repository, ran some sort of machine learning intelligence on them, and indexed them in the Elasticsearch service. And when you put together all of the infrastructure, you start to get this very, very long list of different services that are all talking to each other. And so you get this diagram like I'm showing you on the screen here. And one of the difficulties with this is that when you then want to add a new type of file type or you make a change to a function, you end up with very, very large SAM templates or serverless framework templates. And it becomes more like you're managing this big application again than managing something that's small. So I decided to break up this application using the event bus. And what it actually broke down to was 5 different sub-applications. And this was really interesting. So the final version of the application is in this repo. And I broke down each part of this. It's not screen sharing, sorry. Not sure why that is. Okay, hopefully you can see this again. So this was the original application that shows how complex it can be without this event separation that's going on. And anytime I want to add a new file type to this system that was analyzing files, I'd have to then go in and add Lambda functions. And as you might know, if you're building SAM or serverless framework applications, typically you have to make the bucket part of the deploy. I mean, there are hacks around it, but it's not particularly great. Whereas when I could separate it out using an event bus, I built 5 distinct applications. So this repo, if you deploy this, you'll see this application in its entirety. But the kind of 30,000 foot view of this is that in the first step, we have some infrastructure that simply deploys buckets, and it creates a cloud trail for you, then feeds the EventBridge. And so that's kind of application one. And then application two that parses the files actually doesn't know anything about the buckets. And so the really neat thing about this is that you end up really separating these applications into smaller and smaller pieces. So if I look at this parser function example in number 2, over in the repo, you'll see that these are really, really tiny applications that are most of the time, 50 to 100 lines long. And when you look at their deployments, now all they have essentially is an event rule saying what they're listening to and what the function is to invoke. And so if you think about this from the point of view of an enterprise application, if I were a team working on this one particular piece of the pie, I'm no longer having to worry about absolutely everything else in the system. So to me, this was a really easy way to see how powerful that sort of separation is. But if you go to that repo, the decoupled document repo, you'll see what I mean. Another one that I just put out on Monday, if I just go to the same repo, is the way you can use S3 with EventBridge is actually very flexible. So again, this is a compute blog post that I put out there. Hopefully it loads up, yep. So if you want your S3 buckets to talk to a Lambda function or something else, that coupling can be a little bit tough because often if you're deploying these applications, you have to deploy the S3 bucket as well. But in an enterprise, often you've got multiple S3 buckets, or you might have dynamic S3 buckets where you want to match on a name. Maybe you've got, accounts January, accounts February, and the bucket doesn't exist yet, but accounts March is the one you'll want to pick up next month. And so you end up with this situation where you really want to separate the infrastructure from the things that are happening to the events. So this really was an interesting example because what I did was I showed how you could use existing buckets and listen to multiple buckets to feed events. And in the most extreme example, you could essentially take lots of buckets in this case and use a rule to feed lots of functions. So what I can do is I'm going to show you this very quickly. It doesn't take very long to deploy. So we'll take this, if you want to try one of these, let me just move this. So I've got Zoom panels everywhere. Okay, so what I can do here, if I just clone this repo, I go into this EventBridge function. This is the simple one, number 1. Let me see if I can make the font size a little bit bigger here. So the SAM template here is very straightforward. All it's got essentially is a bucket, in this case, a source bucket, and a policy, and it sets up CloudTrail here, and then these consuming functions. So we could deploy this fairly easily. Just cd into the right directory. I'll do SAM build, and then SAM deploy. I'll just use the defaults it's giving me. Okay, so this is going to deploy this infrastructure here. So what we can do, I'll just go into the console so we can look at this. So you can get a sense of what just happened. See where it's going. It's still creating the bucket. So let's look at the bucket. Okay, so that's going to be our source bucket for this test. It's just been created. And then what I'll do is I'll open up EventBridge in another window. I've got lots of rules, so make sure I've got the right set of rules here. EB test 1, that's the one. So if you think about the this template, we specified a rule in here. You can see that rule just there. And over in EventBridge, now that rule has been created by SAM. So that translated into this. So this rule is listening to events coming from S3, the source there, with the pattern of this bucket name. And it's going to listen to a put object event. Now, when this is completely deployed, yep, we can see a target's now appeared, which is, this is the Lambda function that will be invoked. So if I open up Lambda I'll just bring this function up so you can see this. And I'll bring up CloudWatch just here. So nothing will have run so far. So now we go back to this where this has now been successfully deployed. So what it's going to do now, if I then upload any file into this bucket, so I'll just find some file to put in there. I've got pictures of cats here. Great for machine learning tests, by the way, pictures of cats. And so I've uploaded cat1. So this will have triggered the rule in EventBridge over here and then routed it to this Lambda function. If I go to this and just refresh this display, you'll see that there's a CloudWatch log. And all this function is doing is just logging out the event. But one of the interesting things is you get a lot more information in these events than you would do if you just do a native S3 to Lambda integration. So you can do things like deploy Lambda functions based on source IP addresses or on the principal of the person who uploads the object and various other things. So it becomes very, very powerful. And when you look at these sorts of templates, it's really very trivial to set it up, where the hardest thing is really setting up the CloudTrail setup, which is in there. But the function itself, when we go into that, again, is simply that. It doesn't know where the event comes from. So you're writing business logic without thinking about the plumbing quite so much. So I definitely have a look at these examples pretty closely, because when you deploy these, you'll see how they work. And like all these things, it's much easier getting your hands dirty and seeing what's going on. I've written a number of these different things in the AWS blog. So you'll see me if you search my name. I've written lots of different EventBridge stuff. And then all of my GitHub repos are in github.com/jbezwa, same as my Twitter handle. And you will see all of my different repos there. So that's a really, really fast view of the whole thing. So I'll stop the screen share so I can see your comments, because I can't see otherwise. But let me just take some of your questions again. So I'll read what we're up to here. Is all this getting logged into the schema registry too? Actually, no, I'd not activated that. So what you need to do to be able to use the schema registry is go onto the bus and activate it. So if you do that, then it's listening. There's an additional charge for putting events into the schema registry. So one of the best things to do is to use that when you're in development, but not use it in production if you get an enormous number of events where things are not changing. But there is a charge associated with using that. What I'll do is I'll paste this GitHub repo as well in the chat. So if anybody wants to follow that, they can have a look there. So I think essentially what this offers you using events is a really simple way to decouple services in your applications. And given the fact a lot of us work on applications where new functionality comes in long after we've built the original versions of things, it actually enables you to extend applications very easily as well without modifying existing code. I mean, you look at the way this has been developed. EventBridge is a very, very simple service to use. You simply build this parameters object, which is an envelope with your JSON object around it, and you put it on the bus and set up the rules. So you can set up the rules in the CLI or through the console or through SAM or serverless framework. And then that's really the hardest part of it, because then the rules do all the rest of the work for you. And so a lot of this is about just looking at how you can separate some of your applications. So there's a serverless hero called Ben Ellerby who wrote some interesting stuff recently about EventBridge storming. Because often when you're designing things around events, you have to think about different ways of re-architecting things. And so there's some interesting ideas there about how you can think about breaking apart your applications from an event perspective. But once you get to that point, really using EventBridge is pretty straightforward. What are the event delivery modes with EventBridge? At least once, etc. And can they be configured? So with EventBridge, what happens is when it delivers to a target, if the target fails for some reason, so if you imagine if it delivers to a Lambda function, and for some reason Lambda is unavailable in an availability zone, EventBridge realizes this and will retry continuously for 24 hours using exponential backoff. So If the event is consumed and it's reported back that it's been consumed, then obviously it doesn't. But in the event there's a problem, it does that. However, if you need to have something that's very, very resilient and you cannot lose a transaction because you find that your Lambda function failed for some reason or it didn't do what you expected, this is a good situation where you can have EventBridge talk to SQS and actually deliver to SQS. So what I've found is you can do some interesting things by combining EventBridge with SNS and SQS, because they're all relatively inexpensive services and they all have slightly different pros and cons in terms of retry methods and different targets and things. But there's nothing stopping you putting them all together. They actually natively work together really well. Let me know if you have any other questions. How did you get a haircut? I love that. Yeah, a hair salon opened up nearby, and my wife pushed me in there as fast as possible. So that's how that happened. Are there any integration patterns in the GitHub repo with Kinesis? No, there are not currently, but we're working on those next. There's some really interesting things you can do there. One thing I do have that we have this workshop called Innovator Island that I rolled out at reInvent last year. Let me just paste the URL. This is something we do as an AWS workshop, but you can absolutely run through this code by yourself as well. And we're doing a virtual version of this coming up soon, which I hope is on June the 8th, I think. But using that, we actually talk about how you can use Kinesis with EventBridge. So there's some information there as well. Are there any uptime limits to EventBridge? Are there published numbers? There aren't any published numbers, but EventBridge comes from CloudWatch Events. So this is not actually a brand new service. This is an evolution of CloudWatch Events. And it's used extensively throughout our infrastructure. So currently it processes trillions of events per month. So it's massive scale. So we don't publish any uptime numbers that I'm aware of, but it's pretty resilient. It's worth actually adding to that, because if you think about when events are put onto the bus, so you saw that one line of code that said eventbridge.put events. When you get the 200 response back from that saying that that's happened, in the background, what it's actually done is it's written it to an internal store, the service, in 3 different AZs. So it's a common device used in AWS services that gives you that level of resilience, that to make sure that data doesn't get lost or there aren't problems, that actually the moment you get that response, it has been written in multiple places. I'll also add on this that EventBridge being fairly new, so it came out last year at New York Summit, so there's a lot of stuff on the roadmap coming down the pipe. And so what's exciting about this is we're seeing a lot of very large customers doing all sorts of things with event buses at real scale. And so I've seen a lot of things in the roadmap that make this a pretty exciting service coming up. But it also means that, and again, many people don't realize this, the way AWS builds services is we get all of the ideas from developers and customers. So if you have ideas in using this service, and you want to see features or things working differently, the best thing you can do is tell us, because I work for the serverless teams and we get those things directly on the roadmap. We don't actually come up with these things by themselves. They're all written and developed in response to what customers want to do with the service. Is it possible to sync event buses across 2 regions? Yes, you can send events from one bus to another in different regions, and you can also do that across accounts as well. So it's one of the services that can be useful in terms of getting data across regions for different reasons. Do you think EventBridge will get a GitHub feature roadmap like the containers team? I think, Andrew, you're referring to like a public roadmap. I don't know is the answer. So a lot of teams internally really like these public roadmaps. And so there's a lot of people that really like to see that, because, as I'm saying, we get these ideas from our customers. we actually make that much clearer if it's public in many respects. So a lot of people are real proponents of the idea of making these things public. Right now, the EventBridge roadmap is not public, but in the future, certainly that could be the case. Is it possible to sync event buses across 2 regions? I think that's, yeah, so basically you can, when you say sync, essentially you can send events from one bus to another in 2 different regions. Oh, I see. And that's how you could do this. It's not sync in the sense that the state of the buses is the same. So they're in separate regions. If you have rules and you want to deploy those to separate buses, you still do that as 2 separate deployments. Can EventBridge handle spiky event traffic? Yes, it can. So yeah, so it handles trillions of events per month, which is mind-boggling in terms of scale. The soft limits we put in place for customers of 2,400 transactions per second are more designed to protect you, to make sure that your infrastructure is doing what you expect it, so you don't get bills unsurprisingly. So if you need higher limits, you simply request those through the support center. We have customers who are putting hundreds of thousands of transactions a second into this system, but you don't need to pre-warm it at all. You don't need to do anything to prepare the service. It will simply absorb that load. I don't see anything else for now, but yeah, so definitely with EventBridge, we have also a learning path available, which is worth checking out. I've put a load of different resources on here. Let me just paste this into the chat for everybody. This is something where we've brought together a lot of different videos that I produced on how you use it. Shows you how to connect to SaaS providers because they're all a bit different. So it shows a few different ones there, including people like Zendesk. And so it connects lots of different materials we've put together. And then in addition to the blog post, if you use some of this with the GitHub stuff, you should be able to use it fairly easily. Now, we're really interested in getting your feedback on this because we're still developing lots of features. So you can contact me anytime through Twitter, JBESW, or you can send me a message in LinkedIn, or you can contact me at Amazon. It's jbezic@amazon.com via email. Pretty much anywhere you can find me, I'm listening somewhere. So wherever you are in the world, whatever size of user you are, whether you're an enterprise or you're a startup, we're interested in making this work well for you. So definitely as you start to play with it, keep in touch. Now, if you find things that are not clear or difficult, documentation should be better, don't be shy about telling us that too. We're always interested in seeing how we can make it easier for people. Is there a default interaction ID or event ID generated per event to help a debug failure path from producers to consumers? Yes, there is a GUID that's generated as it goes through the event bus. And so there's an envelope around your event details that is attached. It includes a timestamp, event ID, and various other parameters. They're compulsory because they're an envelope that's been put around, and it does contain that unique tracking ID. One of the things I found very useful, because we don't mandate how you use an event bus, it's really pretty loose in terms of what you choose to do with it. So if you're logging events to the bus and you have rules that you're trying to debug, are they triggering, not triggering, that we have some metrics in CloudWatch logs that tell you how many events are arriving, which ones are being matched. But also one very useful thing is you can create a very general rule that simply logs everything out to CloudWatch. So when you're in the development stage of your application, then you know that the event arrived and you can take a look at it and see what's going on. Obviously in production, you don't want to do that because there's costs involved, but in terms of understanding when you're debugging and developing, it's actually pretty useful creating a general rule that logs everything out. Oh, thanks, George. I really appreciate this. That's very kind of you. To me, this is actually a fascinating subject because I really believe I've been with serverless since almost the beginning. And I originally came from EC2 where we managed lots of software projects. And I thought things got fairly complicated with some of these projects. And so initially when I got to serverless, it's really a simple way of releasing your teams from a lot of admin. And as serverless has grown and become used for bigger and bigger things, we've gone into some of the same traps that we've done in software in the past where your software gets more complicated. So I think this is a really good mechanism for just simplifying things, making it easier for developers and making it easier for producing things for your business users. So I think I'm really excited to see where this is going, though I realize we're pretty early in the journey with events and there's a lot more to come. Can I use X-ray to trace performance from producers to multiple consumers? Currently, no, but X-ray integration is something that we are thinking about, and hopefully we get that fairly soon. Having said that, there are partners you can use if you need to use observability in your systems. If you're using anything like Epsagon or Lumigo or any of those sorts of partner systems, many of those offer solutions to that, but X-ray I think is coming fairly soon. And what I'll do is I'll put my email here as well, so everybody's got my, if you want to send me an email or on Twitter, follow me, DM me, anything you like. If you come up with things related to this or anything else to do with serverless, because my team, we work across everything from Lambda to step functions to API gateway. So obviously, as you build applications, you'll most likely use multiple services. So if you hit anything, you want help or have questions, just let us know.